Here we're finding the gravitational field of a planet that has mass and radius that's compared to Earth. What makes these problems nice is there's a trick that we can use instead of having to use all those large exponents that are commonly in these problems. So what we're going to do is we're going to use Newton's law of gravitation. The gravitational force is big G m1 m2 over r squared. And remember that the force of gravity is also little m little g. And if we divide everything by the mass, so we take each term divided by mass, mass cancels out of the equation and for little m little g, so we can find that the acceleration due to gravity or the gravitational field ends up being equal to big G times the mass of the planet divided by the radius of the planet squared. We can compare this to Earth, and we know that little g on Earth is 9.8 newtons per meter, or we commonly say that that's 9.8 meters per second squared. What we're going to do now is find out this new planet. So the gravity of planet X is big G times the mass of planet X divided by planet X radius squared. Well, we know that the mass of planet X is 4 times the mass of the Earth. And we know that the radius of planet X is 3 times the radius of the Earth. So what we do is we bring that over and we put that into the equation. So the gravity, now instead of putting mass of planet X, we're going to put 4 times the mass of Earth. And instead of radius of X, we replace that with 3 times the radius of Earth. And we need to square that quantity. When we do that, we can find out that this is 4. We just distribute that. We move that out front. 4 times big G, mass of Earth. And that's divided by, well, we square this out, 3 squared is 9. So in the denominator we have 9 times the radius of the Earth squared. And if we look at this section, we have big G, mass of the Earth, radius of the Earth squared. Well, that is little g for Earth, which is 9.8 newtons per meter. So what we have now is 4/9 times little g. And if we do the calculations for that, we get 4.4 newtons per meter, or again, we could use the units meters per second squared. Now, the one thing to remember is that denominator is always tricky. It's 3 radius of the Earth squared, and it's the quantity squared, so make sure you don't forget to square that 3 and make it a 9. So this is a nice, easy way to get the gravitational field or acceleration of gravity of some other planet if you know how it is compared to Earth without having to actually put in all of those big numbers with the giant exponents and everything.